Hello everyone, we are at Beyond the Formula. Today we will see what is the angle between a line and a plane. Right? So consider a plane here. Suppose we have this plane, say pi 1, and we have this line. We have this line intersecting the plane at this point. Right? L1. We can say L and pi, plane as pi. Right? So what is the angle between this line L and the plane pi? So do we measure this angle directly or through some normal? Right? We have a normal here, right? We have a normal vector n vector, and we will have what? B vector that will be parallel to line, correct? So mostly what happens? We get confused that what is the angle here between the line and a plane. So we see the real life example where these things are used. Suppose a ladder resting against a wall. Here the line and a plane angle concept is used. Again an aeroplane or airplane, you can say airplane taking off from a runway, right? A ramp on the ground. These all are the example where this similar concept is used, the same concept is used, right? Suppose if I say an airplane rises from the ground, what angle do pilots talk about? What angle do pilots talk about? So it is the angle this, right? Suppose this is the takeoff of the plane, this is the ground, so it is this angle, right? This is nothing but ground plane, and we have takeoff as a straight line, so it is nothing but an angle between the plane and line, correct? Now what is the actual definition here? The actual definition says that the angle between a line and a plane is defined as the angle between the given line and its projection on the plane. Alright, this is the actual angle and this is the actual definition, right? Suppose this is the plane and this is the line. Alright, now if I draw its projection, right, so we will incident some light, right? So this is the projection. Suppose this is the projection of the line, right? This is L, then this is L dash. So this angle, this theta, is the official angle between the plane and the line, right? Now what if I know the angle between the line and the plane, right? That is what we need to calculate. So what we will do, nothing but we will use the normal. If I know this angle, right, this is phi. Suppose if I know phi, then I will know theta as phi plus theta equals nothing but 90 degrees. So we have theta equals 90 minus phi, correct? Because normal is nothing but perpendicular to the plane. Now you see we will have B vector which will be parallel to the line L. So we need to calculate what? Phi, correct? where theta is the angle between line and plane, line and plane angle, and phi is the angle between line and normal angle, right? So why we use this normal? Why we use this normal? The simple explanation. It is easy. It is simply easy to calculate the angle between two lines or two vectors rather than calculating angle between a plane and a line, because plane has many directions, right? Plane has many directions. Plane is going here, plane is here, plane is here, everywhere, right? So let's see. We have a line L which has a b vector along it, and we have normal here which has phi angle between them, right? So we will use what? Dot product. We will use dot product to calculate the angle, right? Suppose b vector is ai cap plus bj cap plus c k cap, and normal vector is something, say capital ai cap plus capital bj cap plus capital c k cap, right? So we have cos of phi equals b vector dot n vector over magnitude of b vector times magnitude of n vector, right? So now we need to calculate what? Theta. So we can replace cos phi with 90 minus theta equals b vector times n vector over magnitude of b vector times magnitude of n vector, which gives simply as sin theta equals b vector dot n vector over b vector's magnitude times n vector's magnitude. Now this is the required angle theta, that is the angle between the plane and the line, right? So that's all about angle between plane and a line. Thanks.